So I had a couple handouts that I printed out. It looks like there's more people here than I anticipated. So when the time comes, if you guys can just look over the shoulder of somebody else, if you need to, we're just going to be discussing a couple of these documents. You may not need a piece of paper in front of you. Yeah, we'll get started. So I'm Aaron Davis. I'm here to talk about Appendix B. It's the last 10 pages of the research vessel safety standards. Yeah. The slide's not advancing. So I printed a couple of handouts that we're going to discuss. The people online, if you email me later, obviously this doesn't help you right now, I can give you these documents so you can take a look at them. One is a test procedure that I wrote for Sally Ride, and we can go over that just to, it's a good way of illustrating kind of the trials and tribulations of putting together a test method for one of your handling systems. It's not always straightforward. And the other one is just an Appendix B checklist. There's a couple pages that apply to a system as a whole, and a couple pages that you could use as a checklist for like a single piece of equipment, like a block or something like that. I didn't intend to go over those, but if you see some questions or something, you can email me or ask me after the presentation or something. There we go. So what is Appendix B? It's just a few pages at the end of the UNOL's Research Vessel Safety Standard. I guess it was at the end at one point, but now there's a whole bunch of more appendices too. But the aim of this, of Appendix B, is to improve the safety of personnel and to save our gear from damage as we use it to deploy oceanographic instrumentation. Some people ask me, where did this nonsense come from? It wasn't just grabbed out of thin air. It's actually mostly a restatement of federal law that applies to our larger vessels. To give you an idea how large, we have the New Horizon on the right-hand side and the former Oceanus on the left. Those were just a little under 300 gross tons. The federal law applies to any vessel bigger than that. So Appendix B basically just extends this law to the smaller vessels as well. So what does it have to do with? Appendix B has to do with overboard handling systems. And that is gear used to lower things below the surface of the water, used to tow things behind the ship, and gear that includes a tension member that's deployed beneath the surface of the water. To me, this seems fairly straightforward, but in practice, it can be situational and whatnot. So we're going to go over some examples for you to ponder. My first example is this. So in this example, we have a ship and a handling system composed of a winch, a drum, a tension member, a sheave, got a little A-frame there, and a thing that we're deploying in the water. It has three features that make it an overboard handling system. It is being used to lower a thing into the water or raise it out of the water. It features a tension member, again, that's below the surface of the water, and the tension in the tension member is being transmitted to the rest of the system. So in this example, you could take away the sheave and it could still be a handling system because you can still lower things in and out of the water, and it's still transmitting tension to the ship. You can get rid of the winch probably if you had to, although it would be probably more difficult to get things in and out of the water. Another example, here's a thing being towed behind the ship, but the same principles apply. A tension member below the surface of the water, deploying or dragging a thing. So this is the overboard handling system. So the situational bits. Is this overboard handling system? It's the same stuff. Same winch, drum, ship, tension member, sheave, and thing.
In the water.
What's not in the water?
It is in the water.
The thing's in the water. Is the tension member in the water? No. So in instance. It's not an overboard handling system. So why would this matter? What could this thing be?
Like a glider.
A glider, it could be a buoy or something. Like if this system were a crane instead, and you were just setting something on the water, the rules for an overboard handling system don't apply to that. Okay. And here's another thing. It's being dragged behind the ship, but the tension member, again, is not under the water. This could be a boat. I don't know. It could be anything floating above the water. But we don't need to worry about Appendix B in this case. This is my favorite example. What sort of thing might that be? Again, we have a thing, it's in the water. It's kind of wrapped around the sheet. It's partially on the ship.
A free floating array or a mooring.
Right, it could be a mooring, it could be a ray. So the thing that we're deploying is some big long instrument. It might have a cable or something involved, but it's still our instrument. So Appendix B does not apply when you're deploying, say, a mooring or a streamer or something like that. These are important things to note because some of our systems are doing this, and I get questions, how do I test my winch that has a streamer wrapped all the way around it with a water bag or something like that? Well, you don't have to. And of course, this system, there's no tension member at all. So for those of you with purple robot arms, that's out of your boat. You need not worry about it. So, why is the underwater tension member so important? Let me answer that question by asking another one. What is the worst thing that can happen to an overboard handling system? Well, one of the worst. I'm sure there's other creative things you do to destroy one, but
Rip it off the deck.
yeah, it's entanglement. If a ship is cruising along and all of a sudden your gear gets wrapped up in something underwater, the ship's not going to stop. If your tension member is too strong, then the overboard handling system, all a part of it, is just going to get ripped off the ship. And hopefully nobody's standing between that and the water, because then they're going to get injured. So in our view, anyway, there's different philosophies about designing overboard handling system. Our philosophy, or at least the one in the federal law that we're mimicking, is that the best thing to do when we have an entanglement is the tension member breaks first. And that has the least risk to personnel and maybe financial risk, although that's kind of debatable. People that have really expensive instruments on the end of that cable don't like this philosophy very much. So Appendix B has rules to ensure that overboard handling systems can be pulled on until the tension member breaks or until the tension member is let go of in some way. And let's check out what these rules are. We have rules for how they must be designed, specifically strength and safety features they have to have. They have rules about testing them. That allows us to make sure that they are actually as strong as we think they are. They have rules about how we must label them so that operators and other random passersby can tell how strong this thing is. If they see something happening that doesn't really seem like that sign says it's strong enough, then they can stop work or what have you. Inspectors can see how strong the equipment is. We have rules for how we must train people. That's important because none of this makes any difference if somebody that has no idea what they're doing is operating this gear. They can still hurt people and or themselves. And there's rules regarding how we must document our efforts to do all these things. So the first design rule has to do with the amount of stress that we can have in our handling gear. So stress, if you're not familiar with engineering stress or strain, stress is essentially if you push on something, if you push on a piece of metal or bend it, part of that metal is going to get squished, some of it's going to get pulled apart, and the intensity of this squish or stretch is what they call stress. Okay, and for things that are made out of metal, at least ductile metal, metal that's able to stretch and not just fracture, it has what they call a yield point. A yield point is just an amount of stress. If a force is applied to a piece of metal and the stress inside it is small, much less than the yield point, then the metal acts as a spring. You stretch it, it just goes right back into its shape. It's not ruined. But if something far more than the yield point, if a force that's big enough to stress the metal far beyond its yield point, the metal just stays bent, it's ruined. So in order to keep this from happening in our overboard handling systems, the first rule in Appendix B is that the most stress that you can have in your system is the yield stress divided by 1.5. What does that mean? It's just a fancy way of saying that whatever yield stress of the metal is, you can only put 2/3 of that on the system. So if your steel yields at 36,000 psi, it has to be designed so it never sees more than 24,000 psi. That all makes sense. And that's something that mainly just has to do with engineers or manufacturers of the gear. Most people don't need to worry about that particular thing. Another design rule is your handling gear has to have, there's a minimum strength it has to have. For inspected vessels, again, that's the big ones, the system components must be designed at a minimum to withstand and operate in excess of the nominal breaking load of the strongest tension member used. So the nominal breaking load of a tension member being a line or a cable or a wire rope, is just what the manufacturer says. It breaks at 10,000 pounds, say. In practice, it might break it more. Usually it's far more than that. And the strongest tension member used, they say that because some systems can take more than one. It's important to mention this bit about withstand and operate. What does that mean? It means if you pull on it, the whole system has to hold fast. Say if it was a winch, you should pull on it and the brake shouldn't slip. If there's a hydraulic cylinder, it shouldn't leak past or change its position. It does not mean that your A-frame has to be able to like pick something up to the point that it'll break the cable, or the winch has to pull hard enough to break the cable. That's a commonly answered question. So that. So rules are a little bit different as far as minimum strength for uninspected vessels, the smaller vessels. For the smaller vessels, the system also has to be strong enough to withstand the breaking strength of its tension member, unless the system uses a weak link, a torque limiter, or an auto render system. And I'll explain what those mean. So weak link, if you imagine a chain with a whole bunch of really big, fat, strong links and then one little baby one, the little baby one's going to break first. We use such a link in our system sometimes to protect it from getting too much tension. And it's usually used between the instrument and the wire rope or cable. So sadly, the instrument is lost, but the whole system is not lost if you get tangled up. And those have to be something specifically designed for the task, and it has to break at a specific tension. It can't just be, anyway, it has to be fairly accurate in the amount of tension that it breaks out. A torque limiter, our overboard handling systems typically include a winch, and a torque limiter is a clutch, a relief valve, or some other apparatus in the winch that allows the winch drum to slip a bit to turn if the winch is getting pulled on too hard, if the tension's too great. The torque limiter must activate a specific torque, that is when the drum is being twisted at a specific amount by the pull on it. And when the pull on the drum lessens, the winch must operate normally again. It must automatically reset. You can't just freewheel from that point forward. Auto render is a special kind of torque limiter. It's one that's done with software, essentially. It's part of the control system. Something in the system senses the tension in the wire rope or cable, and if it gets too great, the winch just pays out to lessen that tension. So for uninspected vessels, you can have these things to lessen the tension. Another design rule is when you design a system, you have to account for all the various ways that this system might be pulled on. don't just assume that's just gonna be pulled on straight down, or when it's a tow and load or something, consider all the various ways that the thing can be pulled on. To sometimes strength is directional. Our overboard handling systems have to have certain safety features. They need to have guards to prevent personnel and their digits or whatever from getting caught up in them, to prevent people from walking right into a tension member that's under tension and so forth. They have to have signaling devices, meaning they need to have audible alarms when appropriate. They need to have a flashing light or some, say a system is remotely operated, like a winch room, a winch in a winch room is operated from somewhere else. You need to have some indication that that thing is actually energized so that people know to stand clear. It needs to have an emergency stop, not just at the operator station. It needs to have one local to the equipment, because sometimes the operator can't see you tangled up in the equipment. Hopefully that doesn't happen, but electrical safeguards. A system has to be fused or have circuit breakers to prevent from electrical overload. Manual operating devices. The system has to have controls that are the dead man style, they call it. That means that imagine the operator just fall over dead and let go of the controls, the system should stop. So we're talking about operating levers that are spring centered, for example. If you let go of them, it just stops. And maximum capability documents. A maximum capability document is one that at the very least says what the safe working tension of the system is. These are not a requirement of Appendix B right now, but they're mentioned here because when you're in the design phase, when you're getting a piece of equipment designed and or you're purchasing a new piece of equipment, you need to ask for that because that might be your only opportunity to do that. Our companies that make oceanographic equipment are famous for just disappearing, and then that knowledge is just gone. And they will probably charge you absolutely nothing for it when you're buying. So Appendix B is behind here. Appendix B has rules with regards to what needs to happen when you install a new piece of equipment. They're not too elaborate. Install it in accordance with the manufacturer's instructions. Any guards that it was designed to have or that it needs need to be in place when it's installed. Important operational limitations need to be posted. What's a good example of an operational limitation? The safe working tension, for example, need to be posted so that the operator can see them and locally so other people can see them sometimes. Don't sink the ship. What I mean by that is, some gear like an A-frame, for example, on a ship is a major piece of gear. Before you put it on a ship, you need to be consulting with the ship operator or the vessel master to make sure that the stability of the ship's going to be okay. Some of these things like A-frames do affect the stability of the ship. So testing. We do testing to make sure that our gear is as strong as we think it is. That means that make sure that the engineers that designed it didn't mess up, people that installed it didn't mess up, and the ocean hasn't eaten it up. We test our equipment as it's used at sea, meaning that preferably the tension member is wound through all the various bits and it's pulled on just like it would be at sea. Some people feel that you should be pulling on it in every possible way. I've been taking the low bar because not everybody's even met the low bar yet, which is at least to read it through the whole system and then hang a water bag from it. Don't just hang a water bag from the A-frame, for example. We test and assess our equipment when it's brand new, and then we do it every 5 years after that. When you're testing in a system that's brand new, we make sure this system looks like it's suitable for what it's used for. And we test it as it's used at sea to 125% of its safe working tension. For most systems, the safe working tension of the whole system, the weak link is the tension member itself. So you'd be testing it to 125% of the tension member, but not always. You remove all access covers and inspect it after you do the test. And do a more thorough test if you think something terrible happened, if it makes some terrible noise or things don't seem like they're in the right place anymore. Obviously, you need to do a much more thorough investigation after you test. After we initially test it, we test it, our gear every 5 years after that. Each component of the system has to be tested as it's used at sea to 125% of its safe working tension. Now, this may be my recommendation, especially if you work on a ship. You may as well test the whole system all at once. And I think that's less time consuming. But like we test the whole system with a specific block for example, but then we might have 5 more blocks. We're not going to test the whole system 5 more times. I just ship the other ones off to a rigging place and then they test those components. I just tell them, when you test them, test them to 180 degrees of rapid, for example. So we test it as it's being used at sea. So it doesn't matter if you do this testing one component at a time or all at once. I recommend all at once if possible. The plus about testing the system, especially if it's a portable system, if testing it all at once, you're testing everything, including the deck sockets, for example. One component that we don't have to put a load on to test is our deck hardware, and that's our shackles and pair links and bolts and whatnot. Instead of a load test, we inspect them, make sure that it has the manufacturer's markings saying what grade it is or what strength it is, and then discard the ones that are broken. Deck sockets are and aren't a special case. If they're part of an overboard handling system, again, you have to test them just like everything else. I feel it's easiest to test it with a winch on it or with the whole system assembled, and then you're actually testing the sockets as they're being used at sea. There are some contraptions that are being sold and whatnot that test the sockets one at a time, but quite frankly, I don't see how the test itself really translates to how they're being used at sea, or at any rate. I'm not saying that they're bad. I don't know how to translate to a real overboard handling system test. Now, you only have to test the ones you use. Some people would say that you have to test all your deck sockets, but if they're all on the O1 level and you're just using them to like bolt down cargo or something, then it's not part of a handling system. You might have to test it for some other reason, if your organization just has a procedure, but you don't need to do it for Appendix B purposes. So one last little bit while we're talking about testing. As I mentioned before, I brought this testing procedure that I put together for Sally Ride for us to kind of examine together. Partially because not because it's the finest example of a testing procedure. I mean, everybody's is different, but just because there's a story inside here that tells how hard it can be to make such a procedure. And if you haven't made one for your ship yet, you might learn something that we learned the easy way instead of the hard way. On the first page of the procedure, there's a lot of extraneous information in here. And the reason for that is because people always ask me that information and I get tired of going and digging it up later. So why is this required, you ask? Well, number one, it says UNOL's RVSS Appendix B requires OHS to be tested to 125% of its safe working tension every 5 years. So here's the answer to that question. Number two, this procedure assumes the nominal breaking load of the system's 322 diameter cable is 10,000 pounds. The safety factor used with the cable is 2.5. So the cable safe working tension is 4,000 pounds, and the minimum required test load is 125% of that, which is 5,000 pounds. So why are we testing to this weight? Here's a curveball. Our gear happens to be far stronger than that. So the master of this vessel wanted to test to a much higher tension. So is this gear strong enough, I was asked, to do this. So in this procedure, the test load is 10,000 pounds, which is less than the safe working tension of the Allied CTD 11B, that's the robot arm, the starboard side handling unit, the Markey Cast 6 winch, the Smith-Berger 322 guide sheet. Step 4, verify the dyno that will be used is properly calibrated. Step 5, verify the winch's tension meter is properly calibrated. Step 6, disable the winch's render and recover function. It's very important. Now, if you're going to test the system for the first time, I would advise you to call up the manufacturer and see if there's any hidden render and recover function. This particular system has a mode that's render and recover. It also had a secret, limit programmed into the system that we discovered when we filled the water bag with 10,000 pounds of water, and it lowered the whole water bag right on top of the valve that lets the water out of the bag, which made for a long day. So we don't do that every day. Remove the termination from the CTD cable if required and completely haul it in. Haul in the CTD as redundant cable completed. Like I said, this isn't perfect. Reeve the length of 3/8" diameter Samson AM steel blue line through the OHS with a splice line on its working end. This will be the test line. So why do we need a test line in this case? Right. I mean, if we were just going to test the system to what Appendix B says it needs to be tested to, 4,000 pounds, that's fine on a 322 cable. You could just use your 322 cable and hang a water bag from it. But like I said, in this case, we wanted to test it to a much higher load, a load that would break the 322 cable. So one way of doing this, and this happens sometimes to our trawl system, and it has, sometimes it has a 20,000 pound, yes, sir.
I'll let you finish what you're saying. Right.
Well, sometimes you need to test it to something above the breaking strength of the tension member that's on there right now. What was your question?
Would you have to repeat the test with the tension member in order for it to be testing the whole system?
Well, it's testing the system as it's used at sea. It's not testing the cable.
Yeah, which
right.
is part of the system.
But the cable is already tested via Appendix B with a brake test. So in this test, although it is part of the system, we're really just testing everything but the tension member. And really the only way of doing that when you need to test the system to an amount that's above the tension, the allowable tension of your cable, this is the only way we've really found to do it, is to get a synthetic that is slightly, hopefully way more, but the diameter is kind of limiting, stronger than the tension member itself. So what we did is we reeved the length of the 3/8" diameter AM steel blue line. We just spooled a whole layer of that on the top layer of the winch, and then we pulled on it that way, so the winch kind of acts like this capsule. Now we found that this works just fine on top of a nice tightly wound 322 cable. It works just fine on top of a nice tightly wound 681 cable, especially if it's a cable on a traction winch. It does not work very well on a direct pull winch with 3x19 wire rope on it. It'll dive right down beneath those layers, cut the rope in your hose. So I don't advise doing this on a winch with 3x19 wire rope on it. If you do, I would wrap a couple. What we did on the sproul was wrapped a few layers of canvas on top of the wire rope. Then we wound the AM steel blue on top of it. So lash the test line to the bitter end of the CTD cable, haul in until there are 10 or more wraps on the winch drum. Then attach the dyno to the splice line on the test line. Attach the water bag to the dyno. Place the side handling unit in the cast and towing position. This is specific to this piece of gear. It has to be in a certain position to have the right amount of strength. It has a big jib you could stick out and stuff, and it would be harmful to the machinery to have that extended. Ensure the jib is completely retracted and within the limits shown in the figure 1 on the following page. Ensure that it remains that way throughout the test. Ensure the water bag's in the proper position for the test, i.e. clear of the side handling unit, the vessel, and not above anything or anyone that might be damaged if the OHS or bag should fail. Slowly fill the water bag until the dyno indicates 10,000 pounds. Check for agreement between the dyno and the tension meter as the bag is filling. Wait for 5 or more minutes. This is arbitrary. It's not really part of Appendix B. Somebody asked, shouldn't we wait? I said, whatever, sure, 5 minutes. And release the water from the water bag if the bag's not sitting on the drain line. Remove the test line from the system. Put the winch's render recover function in the same state it was in before the test was conducted. Let the vessel master and the winch and wire engineer know when the test is complete so they can make a note of it in appropriate vessel logs. NS5, that's our system that we log our maintenances, and in the ULOG's wire pool database. Give the test line to the winch and wire engineer who will inspect it, keep track of the number of tests it's been used for, have it tested and discarded. So when you're using if you do choose to use a synthetic line wrapped over the top of the winch drum for a test, you're probably testing it to a good fraction of its own breaking strength. We didn't know how many times we could do this, so I don't think we still know. So each time we did a test, I send it to the wire pool and they break test it and make sure it's still as strong as we think it is before we use it again. A safer method. If you don't have time or whatever to test it over and over again, might just be buy a new line every time you test it. Although that gets kind of expensive, it's getting expensive. Does anybody have any questions or comments? Yes, sir.
Been wondering, are you using Amsteel for everything, or do you use the plasma ICO? So, do you have a contact with them at Portland because they don't answer it?
I don't have a contact with Portland. We're using Plasma HICO in the fleet for our oceanographic winching and wiring needs. They did all the development with Cortland to spec that line. They have the contacts at Cortland. I mean, if you're having a hard time getting a hold of somebody, I would contact the wire pool and ask them, who do I call? I spec'd out the Amsteel Blue because it's on the shelf. I can go down the street to the, there you go, West Marine and just buy some.
That's what we did for 322.
Right. But I'm not, we're not using it. We're not using it as our oceanographic tension member on our winches and stuff. Yes, sir.
So deck socket testing.
Yeah.
I thought it was interesting what you said, and
Yep.
I completely agree with you.
Mm-hmm.
But I'm not sure JMS sees it that way.
They don't.
They kept dinging us.
Yep.
Every inspection, and
Yep.
that's why we built the testing apparatus.
And that's why we bought one.
Yeah.
Yeah. Ted Colburn is very adamant. It's like you have to test every single socket, and we just don't use all the sockets, quite frankly. And once again, I don't know necessarily. The sockets on the ship vary in strength. First of all, some are strong, some are not so strong, and I don't know exactly how much, hydraulic pressure on the tester is equivalent to, loading my handling apparatus to 125% of its safe working tension. I could figure that out. It'll be a lot of work, and I may have to eventually, but for the time being, my recommendation remains, do that to satisfy the inspection team. We do that all the time. We don't need to do this, but sure, Ted, if that's what you want to see. We can do that. But for Appendix B purposes, you just have to test the ones that you're actually using. Yes, sir.
Having seen a deck socket fail in the face, I think what Ted was trying to say is that to test your winch installation,
Mhm.
yeah, just the sockets you use. that ship's gonna go out and get used in other ways.
Mhm.
And, plan the event, somebody's gonna look at that random deck socket and use it.
Mhm.
That's, I think what it's trying to say is not just your overhead rule system, but the sockets are there. If they're not any good, they need to mark over, fix them, take them out.
Yes, I agree. I agree, we need to mark the broken ones. I'm not gonna argue with your theory about that. It's, I feel that you're right. If we do use the sockets for other things, I was just focusing on the handling systems themselves. And if we install a system in exactly the same sockets as last time, for example, and we already tested them, great. But that doesn't always happen either. You might think it's in the right spot, but it's really over here. So it's not a bad idea. But
You're absolutely right. Most of them, we used to lash down on a pallet that weighs 100
Right.
pounds.
Ted wanted us to test our sockets on the 01 by the winch deck where we just stored
But
it.
some pallets, we use those for race things.
Yes, sir.
The only reason I joined the safety committee is because what I'd like to see is that people's opinions on the matter,
Mhm.
that the language is very clear in Appendix B on what's required. And Ted's opinion isn't a factor. Because I
Well-
think the RCRBs, they just decided on like a 10% random sample of check sockets. So it seems like everybody's doing it a little different.
Well, the inspection team doesn't always only consider Appendix B too, or whatever safety regulation that they're looking at. And sometimes it's best practices. There's nothing in here that says that you have to have a document that says how much you can luff on an A-frame. And that's not even overboard handling system in that particular instance, but should you know that? Yeah, that's helpful. You need to know if you could pick up that buoy and luff it overboard without breaking the frame or something like that. So that might be one of the reasons why they seem to invent things, but maybe they're not. Maybe I just don't know the other regulations that they're leaning on. Yes.
So, one of the things that I've been kind of struggling to understand, at least the importance and like, the seriousness of is if I get a winch from the winch board, or if I get a winch from some outside group, and I say to them, I need to see whatever documents you have, the Appendix B stuff.
Right.
If you don't know what that is, you certainly should by now. Here's the list. And then they give me that information, which is awesome. But when it lands on my back deck, am I required to do a full test? Because it's not been tested on my ship. And wherever it might land might be some new spot with deck sockets that aren't often used in that way. Do I need to do a full 125% testing
Well,
through the entire apparatus?
my first comment is I would advise everybody, nothing should ever just show up at your deck that you don't know anything about. I mean, this is ideally, right? I mean, that's not really what happens, but I encourage everyone to, during the pre-cruise meetings, to ask them over and over, do you have a winch? Do you have a block? Do you have anything that you're going to be using to lift things, drag things behind the ship? Because if so, we need to know these things about them. And then if that conversation is started early, hopefully if they don't have the right information, they get something else, or the pool can give them something else. But yeah, that's the worst case scenario is they're like, oh yeah, by the way, winch, and you've never seen it before, you don't know how strong it is, et cetera, et cetera.
But even if they have all that information, it's literally coming from the winch board.
Right.
And it has all the documents that it's supposed to have when it lands on my ship.
Right.
Is the first action 125%.
Because it's a portable system that you're going to mount to your deck and use with other things on your ship, you need to test that to 125% of the sync working tension.
So the answer is yes.
Yes.
It should be done.
Yeah.
Please don't put that in the text.
What's that?
Please don't put that in the text.
In the text? Well, it's already in the text. I didn't put it there.
That's what I mean, like,
Yeah.
that, is that what this says? It sounds like yes.
Yeah.
Overboard handling system.
Right. Well, every 5 years, I mean, I don't know, you're probably not gonna see the same thing unless it's, you know, like Hots or Cow Coffee or something where they do it over and over and over again, you know,
Well, I think that's where the component testing comes from. So if that system has been tested anywhere
Right.
within 5 years,
Right.
that's been tested. and then
Right.
That's where the deck socket. So when you're bolting it down to those deck sockets
Right.
have been tested within 5 years, then you take it. Every component and you match it with some other components that are on your ship. With the total system. So
right, it's been tested piecemeal. Right. Yes, sir.
How would you do this? Say, Lance, and you're in Guam and you can get water.
That's a good question. That would be difficult.
We got enough water bags. Actually, if you don't mind, I jump in on the next one. So first, I should mention that you don't have a shortcoming organization when it comes to my question.
Mhm.
I expanded these on the four capital Pacific Ocean, so about on so we're not under UNOS. We love to be, but we don't meet the criteria. We get equipment all the time, right? And
Right.
my purpose to be in this room is so that we can meet what you guys want to see in RVSS, especially when that equipment comes. So I think that's what we're looking at. I actually have this equipment on board right now. I don't think, I mean, we have water bags all over the place, but we do not have the time or the turnaround to start doing testing. I mean, these are maintenance items you do on dry dock, long-term maintenance, that sort of stuff. So do you have documentation that we could lean on? I mean, I could never, I love, by the way, the wording as you can see. I've sailed for over 20 years and I've actually never noticed that wording before. So that's awesome. But do you have something that I could ask an NSF or NOAA team for when they bring equipment on board? Because it does happen all the time for us.
Yeah, I mean, I passed around like a checklist.
Very good checklist as well, thank you.
I mainly made that so that we can go through our systems and look to make sure that we're checking all the boxes. I have never given that to a science party or anybody else, because I don't think that they'll know what they're even looking at. That's a good question. It would be, I was thinking about this recently. We're dealing with, we have an ROV that we're gonna put on the belt pretty soon. That it would be nice to get a document put together. I should put that in a document, a plain language document that spells out more plainly, you know, here are the things that we need to know about your equipment, or here's what you need to do if you're going to use it on a ship. So that would be a good task for me.
Yeah, I think you're on a good line here. This is actually something that the US does, right? So if you go OSHA and you go, especially WAC code, when Washington State, we love our WAC code, almost as much as OSHA, Cal OSHA. For cranes, when we put up mobile cranes around for big projects, anything from GMK or even bigger than that, the documentation requests we have to do, one of the biggest things we need is obviously the annual inspection, but we ask for the checklists to get the actual details on what was done during that inspection. I mean, if you could provide me with something like this as an attachment with whatever winch, ROV, whatever you wanted to send over on board any NSF, entity or university in general, that would be, in my view, a really good way of doing it. That's already established on the construction and general industry side. So just a suggestion.
I actually, now that I think about it, I have made a similar list for a previous version of Appendix B that just applied to like just a block or just a winch. So it was pared down enough to where it wouldn't be overwhelming. There's a lot of that only is situational. Like you don't need, we'll get into it later, but there's training requirements. You don't need a training program for a block.
Is there a way to incentivize science parties to do like the component testing? Because it can kind of go two ways. If they don't really know what they're doing and they're not testing their components that they're bringing with them.
Right.
And then they bring them to the ship and it's like, well, because the ship will take care of it.
Right.
But it takes time, effort, like all the things. So is there a way that like in the appendix that we could say, you know, your stuff isn't fully tested, expect to be spending extra days in court, and that's gonna be paid for with science.
Yeah, once again, these are conversations that preferably happen way beforehand. So you're right, you're right. They-
But if
think
you're
they're
like, yeah, I'll
going-
get it to you, I'll get it to you, I'll get it to you, and
Yeah,
then
they're
they never
not-
do, and they show up.
Anybody that's faced with paying for an extra day of ship time to test something is gonna have a cow.
I should piggyback on that, pretty sorry, just, keep in mind that every time you're testing it on board, you're putting articles on load. So being a former captain, if that wasn't written that I have to do that and I calculate for it, I'd make an absolute no, because you're providing me with equipment that's supposed to work, and I don't want to put the load on my mash finish or the A-frame or anything that I don't have to. I already know it's done its annual and I'm doing my maintenance, so doing that, especially several times a year, where somewhere around, or about 15, 16 expeditions a year, to do that every time, even if I had the time, I would still, as a mariner, as a captain, I would absolutely say no to that, because it's straining on my equipment as well.
Yeah, it is actually,
And then a risk factor for human interaction with any test, it's always a lot higher.
Yeah. It is actually on the vessel master. Go ahead.
This feeds into the comment earlier though about having a more clearly established process that engages all stakeholders, locks in to a very high degree what everyone's bringing, what the expectations are of the captain, the technician, your science party's bringing, needs to be mapped out a lot more thoroughly, so that we're reducing.
Takes time.
Yeah.
It's like 6 months is like the latest this stuff should start.
Yeah, but science often doesn't even know what they're doing 6 months. out.
Well,
Exactly.
Yeah.
That's the
Good
problem.
way to get them on the start thinking about it.
Yeah, but with the more, but Tim, the problem is that the more interdisciplinary some of these cruises get, and the PIs don't talk to each other, and they don't get their missions aligned, and then
We've
they
been
all.
doing it in our program for a very long time. It's not a perfect system, but there is a path.
Some of it's also just.
I have two things I wanted to touch on. One is literally dredging falls in this category. Anomaly of deep water dredging is that the tension is not in a place where you can put the weak link. Tension is at the head ship because of the weak link.
Mhm.
So can we still dredge within the
Mhm.
rules of the 10 feet?
Yeah, I mean, it requires that you know how much wire rope you're gonna have out, and therefore how much weight you're gonna have on it. I mean, you're gonna have a weak link that fails at like a few thousand pounds, not
Yeah.
20,000
15
pounds.
or
But I mean, that's what we do when we dredge, whether it's on an inspected vessel or not.
So the other comment I was gonna make, I exited this community almost completely when Appendix A came out. Appendix B was gonna come out, it was gonna be complicated. I'm astonished that owing seismic systems, tension number never gets in the water.
Oh, no, there's a,
Don't fall under
well,
this,
it's part of
and
the
yet-
instrument, you know.
Well, the instrument, yeah, the streamer gets in the water.
Right.
But it doesn't get owned by a tension number, it's
Right.
owned by itself. Those tensions.
And moorings are strong. So that's not to say that dangling a mooring from your ship might not be problematic, any less problematic than, towing a tow fish or something as far as entanglement. But in our discussions with the Coast Guard and with the safety committee, that's where they draw the line. That's the thing.
I understand the rules, what the rules, but
Right.
from a safety perspective, and the kinds of things it does. NFP doesn't require that we take those things as seriously as we should.
Any more? Yes.
Two really specific questions.
Yep.
One is about seismic. So the streamer doesn't count, but the umbilical that's towing the guns. Counts.
It's all part of the, is it a floating umbilical? It's all part of the instrument, right?
Yeah, it's also with that strength member is embedded.
Yeah. Just like a mooring has a wire rope or sometimes a big chain that's big around on the anchor and stuff. But it's still part of the, instrument.
So that answer, it can be very hard to test. And then the other is that I'm just trying to spec something to wrap a 9/16 fall winch drum with to test the wire if you're operating at a 1.5 accuracy.
Right.
And so I just heard you say canvas, and didn't think that canvas would cut the jack, but it doesn't.
It will prevent abrasion to some degree. I haven't tested a 9/16 wire rope to, 20-something pounds yet. And we tested a 3/8 wire rope on a direct pull winch to like 13,000 pounds or something like that. The first time around, we cut the rope because it actually did dive. And then we did the wrapping with the canvas and whatnot, and it didn't do it that time. But it may not.
We've under wrapped with vanilla canvas. Wrapped with.
Yeah. Yep.
So I think some of this stuff comes, we're talking about testing, and science party doesn't know what they're doing in terms of their operations. It's also figuring out how to do these tests safely. Somebody mentioned doing tests at high tension. Anybody, I mean, if it's not something that they do regularly, that puts people and equipment at risk. So having some procedural thing, or even send your winch to this industry is doing it, or some place where we could do it, so that's not as burdensome of a thing. I think a lot of times people read all this and they're like, oh my gosh, I don't know how to do this, so they don't, it's like paralysis out of
Right. It's in my blocks and rigging shop.
Yeah.
I wish we had a place to test the winches at Scripps, but we don't. I think they
They have a,
East Coast pool has something.
they have a test
They pull on the building.
that, no, they have reinforced neck sockets in here.
Oh, okay.
different. We're talking about pole testing on the ships and Appendix A stuff. It's the same. So what infrastructure is built into the ship that we can do that stuff.
Yeah. Let's take one more question and we'll wrap up. We have a couple more things to talk about.
Yeah, I'll try to be quick. I've used my whole week as sponge talk here now for questions, so it's a great topic. In fact, great questions. I really like to hear those answers. We're on the same page, so I just wanted to ask, who across the organization, who determines as what is required for us to see, especially variants of sports? Is there a way, and then I guess follow up is there a way that you standardize that across the organization? Just because the safety factor there is also, or we make up all sorts of ways of doing that, but people tend to go a little further out than they should when somebody gives them that freedom, and that actually raises that safety factor too. So is there a standardization or some sort of communication across the board that you guys might be doing between ships, or something to say this is what we do? Like Bendo is going to be a question for me as well. It sounded like you do not have a Bendo short sighted to do it, and the organization doesn't have it.
Right. My low bar is a tension member wound throughout the whole system over the overboard and block. That's the low bar because it's loading the handling apparatus. Say like the A-frame, it's loading it the proper way. Like if you just hang a weight on the A-frame and it's not reefed through a block and stuff, you're putting the whole A-frame in bending. But if it's reefed through the block, you're actually compressing the A-frame. It's a completely different load and the load that it's actually made to do. When Appendix A or B came out the first time, like 10 years ago or something, people were getting, some institutions were going crazy. They have all kinds of apparatuses built that they bolt on the ship, and they were hiring engineers to figure out how to pull on it every which way. It's very expensive. It's beyond what most institutions can accomplish. I saw some people testing in a way that quite frankly was dangerous. So that's my low bar. When people ask me what is used at sea, a tension member wound throughout the whole system, including the overboard and black. That's what I look at. That's what we do. Does it?
Can be standardized somehow across the organization.
It could, I mean, the safety committee can make an official statement of okayness or something.
Basic practice.
People also just
Yeah.
have the mechanism, is that a standard deck plate that you leave under the A-frame, you get pulled to 25% of whatever retention member, so put a winch on. Well, that doesn't take that much time.
Yeah.
If we have the tools.
Yeah. Admittedly, that might not be the worst case load on the system. Maybe pulling it sideways really hard is the worst case load.
But kind of what you explained would be great, but let's say an A-frame is a perfect example, most of us have one. If it was, the standard is A-frame testing 125% at these 3 points, 1, 2, 3, so pick up, straight up, on the edge, that's what you expect. We've already proven that a wall is okay. We haven't gone maybe as far as everything as you should see, but having a standard that this is the minimum 1 to 3 steps, we could accommodate that for your people when they came aboard. That would be fine. I just put a water bag, so the back, they actually sit right next to my paper. But determining what we're saying every time as it is listed at sea, or as it is used at sea, it's a very vague and difficult concept to be on board if you don't have a vendor that can do it or a step-by-step guide.
Right.
Like this one's a great step-by-step guide. I could use this if you gave me this, but I doubt you could have that for every equipment.
Right.
It's
But I mean, that's one of the reasons I was originally hired, is to make stuff like that for you guys. Admittedly, those of you that asked for my help in the last 2 years have not gotten much of it, because I've been running the actual winch pool. I've been doing as much engineering, but my boss is taking the reins and I'm becoming more available. Hopefully I'll be doing engineering 100% of the time. Now, before I take any more questions, I'm gonna wrap this up because we got 5 more minutes. So we talked about testing. One more thing that Appendix B specifies, equipment has to be labeled. Has to be labeled with the test date, the safe working tension. A diagram is a nice to have. It's almost never practical. You could put one on a block or something to show, like on an overboarding block, you mean it was tested at 180 degrees or the worst case. But like, you're not gonna do that for an A-frame or a bunch of anything else. Deck hardware should have the strength and grade markings already on it. And it should indicate in some way that they've been recently inspected. I'll touch on that in a second because I think it's a fantastic idea about how to do that. So we have to keep logs that have when our equipment was tested. At the very least, it should include the test date, how you tested it, the test method. It should be a written procedure, the name of those involved, and also make entries whenever gear is inspected, repaired, or experiences a casualty, because that's pertinent to the the strength and or reliability of the gear. Well, I guess it doesn't say it here, but your log should be sufficient to tell that every piece of the equipment has been tested, not just if it's a one-hole system and you don't take pieces and use them other places, and that's fine. But when it comes to things like hair rings and shackles and whatnot, how are you going to keep logs to verify that all of them have been tested? There's where my great idea comes in. If you make a log entry that says, I inspected all the hair links and other random things, and they've all been painted pink, then now they've all been labeled in such a way that you could tell that they've all been tested and it's tied to the log. And then if a hair link shows up in an 8 pink, then it hasn't been tested, toss it aside until you test it. That's my great idea for the day. But training, we need to have a formal training program for our overboard handling gear. All the operators that are going to operate it, if it requires one, you don't need a training manual for a wire rope. But all operators have to complete the program. You should do refresher training annually, and the program must also include auditable records. So if an inspector asks for them, or heaven forbid you're getting sued or something, you have a record. The maximum capability document, once again, it's not a requirement, but if you can get one, if you have the information for one, I encourage you to make one or ask for one from a manufacturer. It generally includes the safe and working tension of the equipment, the design line tension. Now that is the greatest tension you could put on it before the stress is too high, basically. Or you could think of it as like, what's the greatest breaking strength tension member I could use on this piece of gear. And reaction forces are nice to have too. Like if it's a block and I load it with 10,000 pounds at 180 degrees, what's the load on the shackle? It's gonna be 20,000 pounds. So the reaction force helps us figure out, you know, what bolts we need to use to bolt it down. If the loads are gonna be excessive on the thing you're bolting it to. Here's a simple example of a maximum capability document made by the manufacturer for one of our blocks. The highlighted items are the safe working tension, the design line tension, and Fmax here is our reaction force. So that's kind of what one of those might look like. I could show you other examples if you need them. Just email me. And finally, the overboard handling system operator's manual is a requirement. It is a requirement for a whole system. Like if you have a ship with a whole system, you need to have one of these. It includes a detailed description of the OHS layout. That would be pictures or diagrams showing how everything's put together. OHS test procedures like the ones that we just reviewed. Your operator training procedures. References to component manuals or data sheets. It doesn't have to be included in the manual, but at least a reference to them. And any maintenance procedures you have for that piece of equipment. It could be an old school document, just a piece of paper and a binder all put together. You can hand to the inspector. What I do is I gather all these together in a PDF format. I make like a table of contents or something in Word and save as a PDF, and then I just use Adobe Acrobat to just smash that all together in a single document, add pages, numbers, and whatnot. And once again, this is something I can do for you. If you contact me, get on the list. I still owe you one for Seculia.
Okay. Thanks for making the one.
Thompson's next. Anybody else wants to get in the queue, send me an email. And lastly, once again, this is kind of a checklist that I put together when we got the new Appendix B. Read through it. If you have any questions, just send me an email because we're out of time. Any more last minute questions before you move on?
I got one.
Yeah.
How long would you say this took? That's half day?
Oh, the test? Yeah, a few hours.
And did you have to move the ship and read it and do a kind of
That's what the problem with the water bank.
Is you have to pipe.
Yeah, it has to be high type.
We've done versions of that on our ship. Off the stern, you know, the ship takes the longest part of draining the bag.
Yeah, filling the bag, draining the bag. Yep. And on the, if you're not using the actual tension member on the system, reading the new tension member through and all that stuff takes a little while.
So the science party has to inspect and get one more to do a test if they want to. That seems reasonable.
Yeah. Like when OOI goes on Seculia, I can test all their gear. It takes, by the time they've tested everything, I mean, they've tested several different winches and whatnot. It takes them all day. But then they account for that. They know that's going to happen. So, yeah. All right. That's all I got.